Hi everyone, in this video we are going to discuss about block diagram reduction technique with a problem. Using block diagram reduction technique, find the closed loop transfer function of the system whose block diagram is shown in the figure. So this is a given block diagram. You have to reduce this block diagram. Finally, you should have the input R and you should have a single block and you should get an output C. Usually you will write a transfer function here. This block diagram has to be simplified by applying an appropriate rules. We will see one by one. Step 1. We are moving the branch point before the block. So here you see here there is a branch point between G2 and G3. We are moving the branch point before the block. So whenever you move this branch point, this path will get affected. So what we have to do, moving the branch point before the block, in the sense we have to multiply with that particular gain. Let's see. You can see here it is H1 into G2. So when I move this branch point to the left side, I can achieve two blocks in a cascade and these two blocks are in parallel and these two blocks are in cascade. Why you are getting a G2? Because we are moving the branch point before the block. So H1 into G2, it is appearing here. Here G2 G3 multiplied and added with G4, that is why G2 G3 plus G4. Now next step, we are moving the summing point before the block. When you do a summing point, a movement, what will happen in the sense, this particular branch is getting affected. So moving a summing point before the block, you have to divide by that block gain. That's why it is 1 by G1. These two things are in series, so you can write it as H2 by G1. And next step, we are interchanging these two summing points and modifying the branch point. Instead of having two connections on a same line, we are making like this, a separate connection, diagrams like this. This is what modifying the branch point. You are interchanging these two summing point. So this path will come inside and this path will come outside. So if you see, the diagram becomes like this. Because of the interchanging, you can get a negative feedback 1. After solving that, these two blocks are in cascade or it is series and these two blocks are in series. Next, we have to eliminate the negative feedback loop and combining the blocks in cascade. When you solve this one, negative feedback, G divided by 1 plus GH. So G1 divided by 1 plus G1 G2 into H1. This is the equivalent. That is in series with G2 G3 plus G4. We will see what is the result. So whenever we combine this one with this block, your answer becomes G1 times G2 G3 plus G4 divided by 1 plus G1 G2 and H1. Now you can see you are having a negative feedback. This particular negative feedback is eliminated. We have solved here. It is g divided by 1 plus gh. Upon simplification, we will get this equation. So here this entire block is replaced by means of this transfer function. Finally, your diagram, this diagram is getting simplified like this. This transfer function I have written here. Therefore, you have an input R, you have a G block. There is no H block, means that it is a unity feedback. That means G divided by 1 plus G into H is equal to 1. Upon solving this, we will get a transfer function like this. G1, G2, G3 plus G1, G4 divided by 1 plus G1, G2, H1 plus G2, G3, H2 plus G4, H2 plus G1, G2, G3 plus G1, G4. This is how you have to apply the block diagram reduction rule and need to achieve the overall transfer function. This is the overall transfer function for the given system. These are the references. Thank you.